right, y'all, today we are actually looking at 5-1, transformations and attributes of quadratic functions. But before we get to all this fun stuff, we actually need to get out our parent function or pink notes. So pause me real quick if you need to and get those out. All right, I'm assuming now that you have those, so let's get started. We've already filled out the first two parent functions, linear and absolute value, and actually the parent function that we're going to be working with today, quadratic, is similar in a lot of ways to absolute value. So let me scooch this up. Okay, so as you're copying this down, make sure you're listening to what I'm saying carefully because that'll help you understand the concept for today. So I know you've had exposure to quadratic functions in Algebra 1, but we're going to deepen your knowledge, okay? So just like I talked about in a previous video with the absolute value function, if you have a function or an equation that you don't know how to graph, then you'll want to choose various inputs to plug into the equation to get outputs so you can have ordered pairs to plot on a coordinate grid. Okay, and I've done just that. I've specifically chosen some negative inputs, 0 to show me the middle, and positive inputs to show me what's happening on the left, what's happening in the middle, and what's happening on the right side of the graph. And of course I could have kept going forever, but these are the 5 that I'll want you to memorize for this parent function. Okay, so how did I get the outputs? Well, I took the inputs and I plugged them, like I just said, into the function. So you plug in -2 here for x, then that would be like y equals the quantity -2 squared. What happens when you square -2? That means -2 times -2. And a negative times a negative makes a positive, so that would be +4. Similarly, if you plug in -1, -1 times -1 is +1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. So then I plotted those points, and guess what? I didn't have to use a straight edge because the rate of change, unlike linear and absolute value when you're looking at each individual piece, the rate of change for quadratic is not constant. Okay, so no straight edge needed. Yay, right? So it's a curved line instead of a straight line, if you will. Okay, so what's similar from absolute value is that this tip point here is called the vertex. All right, so that is the vertex, and the axis of symmetry is the line that cuts through the vertex and cuts the graph in half, right? So this is your vertex, this is your axis of symmetry. Okay, I went back and capitalized that because I think I had it lowercase before and it really bothered me. It's supposed to be capital. So AOS for axis of symmetry. All right, so then let's talk domain and range. So domain and range is actually exactly the same as the absolute value function. You can see why based on the look of the graph. So the domain is x such that x is an element of all reals because this graph goes forever left, forever right. Because I could have kept going, like I just said a second ago, in the negative direction I could have kept going and get more outputs, and I could have kept going in the positive direction and getting more points. So it goes forever left, forever right. The range is y such that y is greater than or equal to 0 because our lowest y value is 0 and they increase from there. Our x and y intercepts are 0, 0, the origin, and no asymptotes just yet. I'm so sorry. We'll have fun with that soon enough, I promise. Okay, so now let's hop back over here to your notes 5-1. Now we're going to take that parent function and we're going to transform it and we're going to talk about attributes, okay? And just so you know, I've taken these points, this table here for the quadratic parent function, and I've listed them on problem 1, 2, 3, and 4, just so I didn't have to keep flipping back because I knew we were going to need them. All right, so enough of that. So let's talk about vertex form of a quadratic. This equation here is called vertex form because you can easily get the vertex from this form. So it's actually really, really similar to what we talked about with absolute value. Remember, for absolute value, it was y equals a times the absolute value of the quantity x minus c here, and then plus d here. So the h and the k are very similar to the c and the d, all right? So it's very, very similar. So you get the vertex is the ordered pair hk, because remember, you take the opposite. So since that's minus h, you'll put positive h here, and then you keep this value the same. So h comma k is your vertex. The axis or line of symmetry, just like with absolute value, is x equals the x value of the vertex. And then this is also just like absolute value. We never spelled this out, but it's the same. So if a is greater than 0, okay, then the graph is going to open up, right? And if a is less than 0, remember that a value, it still does in quadratic, deals with the vertical stretch, shrink, or reflect. So if that a is less than 0, that means your reflection over x. So therefore, your graph is going to open down like this. Okay, so let's get to the examples. Complete the following information about each function. So let me show you how this is read. Y equals negative, the quantity, that tells us what's in the parentheses, the quantity x minus 5 squared minus 2. Okay, you say the quantity, that way you know what's in the parentheses. Okay, that's the quantity. So what's my vertex? My vertex, remember, opposite of what's here, because that moves right 5. So we'll say positive 5. Oh, you know what? I want to use a different color for the stuff I'm working. I'm sorry. So positive 5 comma negative 2. Remember, we keep that k value the same. Then how do we know so this is kind of funny. This is different from absolute value because a lot of times you're asked with the quadratic, is the vertex a max or a min? And if you see that question, max or min but no interval, that just means in general, is the vertex going to be a maximum value or a minimum value? And so let's talk about it and then we'll prove it with the graph. So the vertex is going to be a maximum value because a is less than 0. Okay, we reflect over x, which means the graph opens down, so the vertex will be the highest point on the graph. And what will that specific point be? Well, it'll be the vertex. F of 5 equals negative 2. And when we do the graph, I'll show you. What's the line of symmetry? It's x equals the x value of the vertex. So then we'll graph, and we'll just point out to make sure that we double check these. So remember, we need to multiply our y values by this a value, so negative 1, so negative y. So this will become negative 4, negative 1, 0, negative 1, negative 4. Cross through these. All right, so I have to multiply my y values by the a value, and before I plot, I need to move my origin. So remember, this moves right 5, down 2. Okay, right 1, 2, 3, 4, 5, down 1, 2. There's my new origin, and like I thought, my vertex would be there at 5, negative 2, and then from my new origin, I plot these 5 points. So left 2, down 1, 2, 3, 4. Then I go back to my new origin, I'll remind you of that, and then left 1, down 1. On the new origin, plot a point, that's your vertex, and then from my new origin, right 1, down 1, and then from my new origin, right 2, down 4. Okay, so then no straight edge because this is a curved line. Okay, and then there's your graph. So is the vertex at 5, negative 2? Yes. Is the vertex, since I've given no interval, it's just asking about the graph in its entirety, is the vertex, is this a maximum point on the graph? Yes, that's the highest point on the graph. It doesn't go any higher from there. There's not a minimum value because it goes forever down. So the max is here at f of 5 equals negative 2. And my line of symmetry, if I were to draw it, cuts through the x-axis at positive 5. Hopefully you agree with all that. Okay, let's move along. So next problem. Vertex. So remember, this is red. Y equals 2 times the quantity x plus 2 squared minus 3. So the vertex is negative 2, because we take the opposite of that, comma negative 3. Is the vertex going to be a max or a min? Well, in this case, it's going to be a min because the a value is greater than 0, so the graph's going to open up. And so the vertex is going to be the lowest point, the minimum. The lowest point. If I have no boundary, then I assume it means just talk about the whole entire graph. So throughout the whole entire graph, we have a min at f of negative 2 equals negative 3. We don't have a max, and when we get the graph, I'll show you that again. My line of symmetry is x equals negative 2, the x value of the vertex. Let's go ahead and get busy graphing. So I know I'm going to need to multiply my y values by 2, because the a value there. So 8, 2, 0, 2, 8. Remember, I'm multiplying my y values. Then I need to shift my origin left 2, down 3. Left 1, 2, down 1, 2, 3. There's my new origin, and plot my new points. Left 2, up 8. Left 2, up 3, 4, 5, 6, 7, 8. Left 1, up 2, 0, 0. And essentially, you can mirror on the right, correct? You know that it's a mirror on the right. Okay, so let's double check. Is our vertex at -2, -3? It sure is. Is our minimum value at the vertex, f of -2 equals -3? Yeah, we don't have a max, okay? It goes forever high. We can't say there's a max if they don't give us a bound, and they didn't. Okay, the line of symmetry is at x equals -2. Won't you agree with me that that line cuts the graph in half? All right, we're doing great. Let's keep moving right along. We're making good time. Okay, state the transformations from the parent function, then graph each function. So now it wants the transformations. So I'm going to start with the negative out in front. Remember that negative being multiplied out in front is a reflection specifically over the x-axis. Okay, the 2, remember, ignore the negative now. That dealt with the reflection. I've taken care of that. The 2 being multiplied out in front is a vertical. Remember, if it was inside, it'd be horizontal, but outside is vertical stretch. That's going to be your vertical stretch by 2. The -3 inside is what's going to shift us right 3. And then the +4 outside is going to shift us up 4. So we can go ahead and move our origin right 3 up 4. Right, 1, 2, 3 up, 1, 2, 3, 4. There's our new origin. And of course, we're going to multiply our y values by -2. So that's going to be -8, -2, 0, -2, -8. So cross through those. So from my new origin, left 2 down 8. From my new origin, left 1 down 2, 0, 0, and then mirrored on the right, correct? All right, so have I followed the directions, stated the transformations, and then graphed? Yep, I'm good to go on number 3. Let's move on to number 4. So notice this multiplication here is inside the parentheses, unlike this one here. Okay, so that's going to be our horizontal. And remember, changes inside act opposite of kind of what we think. So this is a horizontal stretch because, do you remember? You reciprocate that value. So it's a horizontal stretch by 3. The reciprocal of 1/3 is 3. So a horizontal stretch by 3, and this -1, it doesn't have any left or right. This -1 moves it down 1. So I'll go ahead and move my origin, and then I'll remind you that now, since I've got this multiplication inside with x, that means your x values are going to change, okay? When you had multiplication outside with y, y is on the outside, x is on the inside, then you multiplied your y values. But when you have a change like that inside, then you multiply your x values, and specifically by the reciprocal. So the reciprocal of 1/3 is 3. So multiply your x values by 3. So I'm doing just that right now. So -2 times 3, -1 times 3, 0 times 3, blah, etc., etc., etc. Okay, so -6, 4. 6, 1, 2, 3, 4, -3, 1, 0, 0, 3, 1, and 6, 4. It's kind of harder to see the mirror image on this one, so I'm actually going to count. Okay, so now I've got my curve, and that's a wide guy, isn't it? That's a wide guy. That makes sense that we have horizontally stretched him horizontally. He's a pretty wide guy there, okay? All right, so now let's move on to the last step, the writing quadratic functions that match the given description. So number 5, the parent function, so the quadratic parent function is stretched vertically by a factor of 5. So stretched vertically by a factor of 5, translated 4 units left, 3 units up, and reflected over the x-axis. Ooh, that's a mouthful, isn't it? So we have y equals. We know that we reflect over x, so that's the negative on the outside. And then we know that we stretch vertically by a factor of 5. That affects y, so that's outside with y. And then let's talk about what's inside with x. So it didn't say a horizontal stretch, shrink, or reflect, so I don't need to put anything in front of x. It did, however, say left 4, so that's going to be your +4. Remember, opposite of intuition. And then 3 units up would be +3 on the outside. Okay, now if you forget the squared, then it's not a quadratic function. So that squared is what makes it quadratic. So that's like the most important part, so don't forget it. Okay, number 6. The parent function is shrunk horizontally by a factor of 1/8. Horizontally shrunk by 1/8. Translated 7 units down and reflected over the y-axis. So I didn't see any vertical reflect or stretch or shrink. So I know there's no a value out in front here. I do know I'm going to have a couple of things in front of my x inside. Okay, I'm going to have a couple of things. I'm going to have the reflect over y, which goes on the inside, and then the horizontal shrink by a factor of 1/8. Remember whenever I said what I said out here, horizontal stretch by 3, I took the reciprocal of what was inside here to get that value. So you need to go backwards and take the reciprocal of 1/8, and that's the value that goes in here. So that'll be 8. That's your horizontal shrink by 1/8 is that. And then I noticed that there wasn't a left or a right movement, so that's why I closed this off so early before writing anything here, because I knew there wasn't a left or right movement. And then 7 down would be -7. And the fact that I underlined that 1/8 kind of looks funny with the squared there, so I'm just gonna erase it. All right, so that's it on that one. We're done.